Welcome students. Today we will discuss previous year physics paper. Last year 2025 का paper है. Code number है 5541. So we'll start with objective questions. So this is the first question. A body acquires the charge 18 to 10 to minus 12 coulomb. Acquires the charge 18 to 10 to minus 12 coulomb. So what is the mass of the body? Mass के बारे में पूछा गया है. Because body has acquired positive charge, this means body has lost electrons. Now how many electrons body has lost? Using quantization of charge to find out how many electrons have been lost. Charge is 18 to 10 to the minus 12. Electronic charge is 1.6 to 10 to the minus 19. So this will be divided here. It will be 5 into 10 to the 7 electrons. So it is 5 into 10 to the 7 electrons body has lost. Because body has lost electrons, that's why it will also lose some mass. So mass, how much mass it has lost? That is number of electrons multiplied by mass of one electron. That is 9.1 into 10 to the minus 31, which comes out to be 45.5 into 10 to the minus 24 kg. Or 4.55 into 10 to the minus 23 kg. So answer is for this question is C part. Please remember, if it is positive charge, then body has lost electrons. If it is negative charge, then body has gained electrons. So this is first question. We go to the second question now. Current flows through a cylindrical conductor of radius r. The current density at the point of the conductor is J alpha r. So we have to find out the current that is flowing through r is equal to 0 to r is equal to r by 2. So I will explain through the diagram here. There is a cylindrical conductor and current is flowing. And this current density is not constant typically. Center में current कम है because distance पे depend कर रहा है और sides पे current ज़्यादा है. So let us suppose circular cross section we see. So current is lesser at the center and more at the sides. हमें करंट निकालना, we have to find out current in a region like this, circular region में निकालना है हमें, जिसका रेडियस वेरी कर रहा है 0 to r by 2. We have to vary the radius. So we take a small region here. First of all, at a distance x, we take a small strip which has a width equal to dx. First we find current flowing through that region, and then to find total we will do integration. So we know that current is equal to क्या होता है? Current density into area. Small current density at their distance x is x distance पे current density क्या होगी? Alpha x. And what is the area of this strip? That is 2 pi x dx. So this comes out to be 2 pi alpha x square dx. Now to find total current, we have to integrate both sides from 0 to r by 2. And you know that everything else is constant. X square का integration x cube by 3 आएगा, and limits will put 0 to r by 2. So clearly when we put the limit, it will be r cube something. So our answer is r cube. The answer is r cube. So just अभी पूरी calculation नहीं करनी थी, हमें सिर्फ आंसर चेक करना था. It is r cube. It will vary as r cube. Next question. There is a magnetic field like this, and charge is flowing, moving in xy plane, and magnetic field is along z-axis, and crosses represent magnetic field is going inwards magnetic field. So किस टाइप का path follow करेगा charge particle? Obviously, when a charge particle is moving perpendicular to magnetic field is like this, charge particle is moving like this, it will follow a circular path. But because magnetic field is only on one side, so it will follow a path like this. It will be only a semicircular path because पूरा circle बन ही नहीं पाएगा, ठीक है? It will be a semicircular path, and that will be obviously perpendicular to magnetic field. Magnetic field is on z-axis, so this semicircular path is on in xy plane perpendicular to z-axis. So इसका आंसर होगा बेटा, it is a semicircular path in xy plane. Semicircular path in xy plane. So we go to the next question. A bar magnet is initially at right angles to uniform magnetic field. So there is a uniform magnetic field like this. Uniform magnetic field is there, and a bar magnet is perpendicular to it, like this. Now it is moved to a point where torque becomes half of the initial value. Torque becomes half of the initial value. We have to find out that point. Torque on bar magnet is given by mv sin theta. When it was 90-degree angle, torque was maximum, sin 90 is 1, torque is mv. Now we reach a point where torque is half of this torque. Torque is half of this maximum value of torque. Half of mv. Torque का formula again we put mv sin theta. So half mv, mv से mv cancel out होगा, sin theta 1 half होगा, that means theta is how much? Theta is 30 degree. So that means we have moved from angle 90 degree to an angle of 30 degree we have moved. So by how much angle we have moved? By how much angle we have moved from 90 to 30? We have moved by angle of 60 degree. 90 to 30 position, the bar magnet has been moved through an angle of 60 degree. Which one of the following materials is not paramagnetic? इनमें से कौन सा मटेरियल पैरामैग्नेटिक नहीं है? Okay. See, in this sodium chloride is not paramagnetic because ions are Na positive and Cl negative. They have fully filled shells. It is 2,8, it is 2,8,8, so they are diamagnetic ions, both are diamagnetic ions. Aluminium is surely paramagnetic. About calcium, what we can say? In calcium configuration, the last it is 4s2 when we write the configuration of calcium, but still it is not diamagnetic. It is paramagnetic. This is because in case of metals, in case of metal ions, we can tell easily. If there is unpaired electron, we can say it is paramagnetic. If there is no unpaired electron, we can say diamagnetic. Like Na positive is diamagnetic. But in case of pure metals, we can't say like this. In case of pure metals, there is, you know that there are kernels and free electrons. So for every metal like calcium, suppose it has 2 electrons in the last shell, so the 3 electrons will be moving outside the nucleus, outside the atom. So due to presence of free electrons, even calcium is paramagnetic. So for metals we can't say like this. So for metals we have to learn. NCERT example we have to learn. Who are diamagnetic? That is gold and silver. It is given in NCERT. And other metals जिनका पैरामैग्नेटिक वो भी आपको लर्न करना पड़ेगा. जो पैरामैग्नेटिक है आयरन, कोबाल्ट, निकल, गैडोलीनियम. So for metals we have to learn. We have to cram it. Which metals are paramagnetic, which are diamagnetic. So ये सब paramagnetic हैं. Aluminium is paramagnetic. Calcium is paramagnetic. ठीक है. Copper chloride it is not sure because copper chloride can be cuprous chloride or cupric chloride. Cuprous chloride is diamagnetic, but this is paramagnetic, so we are not sure about this. 100% sure, which is not paramagnetic, is sodium chloride. It is sure. An emitter is connected in series in AC circuit and reads 10 ampere. In AC circuit, if any device is connected, it may be emitter, it may be voltmeter, it will always provide you RMS value. Hot wire instruments we call them hot wire instruments. So this is RMS value, 10. And we want to know the maximum current, peak value में चाहिए. Maximum value means peak value चाहिए. IRMS क्या होता है? It is I naught divided by root. RMS value is 10, so root 2 इधर multiply हो जाएगा. So what is the peak value? It is 10 root 2. So whenever any current or voltage value is given for AC circuit without any description, then we always understand that it is RMS value, it is not peak value. अगर peak value होगी तो clearly mention होगा it is peak value. Amplitude of electric field in electromagnetic wave in free space is 1000. Amplitude of magnetic field we have to tell. So there is a relationship E naught to B naught. Amplitude of electric field to magnetic field is speed of light. That is in properties of EM waves. Unit 5 में आपको मिलेगा ये. So what is B naught? It is E naught by C. The value of E naught is given 1000. C is 3 into 10 power 8. So divide करके आंसर क्या आएगा? It will be 3.33 into 10 power minus 6. Answer is D part. So you can understand that in EM waves you will always get a question on properties of EM waves. You will always get a question. It is always a question on properties of EM waves. The magnification produced by a spherical mirror is -2. The mirror used the nature of the image form is. So magnification is given to be -2. Minus sign represents that image is real. Okay, real and inverted image, minus sign represents. And real image is formed only by concave mirror. Only by concave mirror. So it is a concave mirror which is forming a real mirror, real image. So B it is. So basically, obviously, this question is on 10th basis. 10th में हमने यूज किया होगा. तो आपको अंडरस्टैंड करना है कि when this question comes, you have to understand this type of question mirror based, which is forming real image, which is forming virtual image. वो आपको वहाँ पे याद करना पड़ेगा. इससे मिलते क्वेश्चन करिए. टॉपिक को रीड करो. इमेज फॉर्म बाय मिरर, इमेज फॉर्म बाय लेंस. जितने भी आपको केसेस पढ़ाए जाते हैं 10 से पढ़ा रहे हैं, वो केसेस आपको लर्न करना है. Choose the correct statement. Photons of light show diffraction, whereas electrons do not show diffraction. Diffraction is a phenomena. Diffraction and interference are both the phenomena which are shown by waves. Photons obviously, photons are energy particles, waves ही हैं. Energy has a dual character, wave character as well as particle character. So photons will show diffraction. Electrons will also show diffraction because electrons also have a particle character as well as wave character. And that was taught to us by de Broglie principle, which says that every moving material particle has a wave associated with it. So that means photons and electrons both have wave character. Both will show diffraction. Second part is saying electron has momentum and electron material particle, it is moving, so it will have momentum. Photons also have momentum. Always remember. Photons के केस में हम दो ही फॉर्मूले करते हैं. एनर्जी का फॉर्मूला होता है hc by lambda and momentum का फॉर्मूला h by lambda. Photons also have momentum. Electrons also have momentum. So this is incorrect. Notice photons don't have momentum. This is incorrect. And light of photons and light electron both exhibit dual character. This is correct. This is absolutely correct. Both have a dual character, particle as well as wave character. And last point. All electromagnetic radiations do not have photons. This is wrong. All EM waves have photons. Gamma ray photon, UV ray photon, X-ray photon, all have. So correct statement is C. Correct statement is C. Photons as well as electrons have dual character. Question number 10. A beam of red light and a beam of blue light have equal intensity. Which of the following statement is true? Blue beam has more number of photons than red beam. Red beam has more number of photons than blue beam. Wavelength of red light is lesser than wavelength of blue light. This is wrong. C part is absolutely wrong. Obviously आपको पता है red की wavelength सबसे बड़ी होती है, blue की wavelength कम होती है. The blue light beam has lesser energy per photon than light beam. ये भी wrong ही है, क्योंकि energy का formula, photon की energy का formula क्या होता है? hc by lambda. Obviously red color has bigger wavelength, so it has smaller energy. Blue will have more energy. So C and D are absolutely wrong. So we have to check only A and B. So we go to the formula of intensity. Intensity क्या होती है? It is energy per unit area per unit time. And intensity का formula क्या है? Energy का formula क्या है इसमें? Energy is obviously hc by lambda into area into n times n photons. N photons. So I write again, intensity is equal to n times hc by lambda upon area upon time. So you can say that they are saying the same intensity, intensity is same, okay. Area is same, everything is same. Okay. So we take it here, lambda and n are directly proportional. Means whichever will have larger wavelength will have number of photons, more number of photons. So red color has larger wavelength, so it will have more number of photons. So we understand this by another way. Who will have more number of photons? Number of photons is basically equal to total energy that is coming divided by energy of one photon. इसको ऐसे भी समझ सकते हो आप. Because red color beam photons have smaller energy. That means number of photons of red color will be more. The red packet has a smaller energy and the blue packet has a more energy. Because red packet has a lesser energy, तो उसके number of photons ज़्यादा आएंगे same intensity के लिए. इसलिए इसका आंसर है C part. Which of the following is electrical conductor at room temperature? So इसके लिए आपको इस क्वेश्चन के लिए आपको यूनिट 2 पढ़ना पड़ेगा. यूनिट 2 में बताया हमने मेटल्स क्या होते हैं, कंडक्टर्स क्या होते हैं, सेमीकंडक्टर, इंसुलेटर्स के बारे में डिस्कशन है सारी. इसके अलावा आप यूनिट 9 पढ़ सकते हो, सेमीकंडक्टर वाले में एनर्जी बैंड वाले टॉपिक में बताया गया है. So वहां से एग्जांपल आपको पढ़ने पड़ेंगे सर. So mica is obviously insulator. Carbon, silicon is semiconductor. Okay, this cannot be answered. Carbon has two forms: diamond, which is insulator, and graphite, which is conductor. So basically, that is also not true. So that means confirmation answer हमारा क्या है? Tin, which is a metal, which is a conductor at room temperature. इसका आंसर tin है. Now we go to the next question, question number 12. A long straight wire is held vertically and carries a steady current in upward direction. The shape of the magnetic field line is produced by the current carrying wire. So if the wire is carrying current like this, magnetic lines will be circular. So we can keep the thumb in direction of current and fingers will tell you the direction of magnetic line. Now magnetic line of course will go inwards from here and outwards from coming from those right side. So magnetic lines will be like this. Circular magnetic lines will be there, and because it is vertically placed conductors, lines will be horizontal. Circular lines concentric horizontal circles around the wire. So answer will be C part. Next question, question number 12. Done. Question number 13 now. Now these are assertion reason questions. In assertion reason questions, you always remember that you should first read only assertion and try to answer it yourself. After that, you should read reason, not before that. N-type semiconductor is not negatively charged. Yes, it is absolutely charged. True, because N-type semiconductor is neutral. It has no charge. It is called N-type semiconductor because it has more negative carriers than positive carriers. हमारे पास सिलिकॉन है. In silicon, which is neutral, we are entering a pentavalent impurity to form an N-type semiconductor, that is arsenic, suppose. Now, when arsenic atom goes here, it will provide free electron. Electron will become free, but arsenic will require positive charge. So, due to the net charge on the N-type semiconductor will remain zero. It is neutral. So, assertion is correct. Now, we read the reason. You read the reason only when you answer the question. Neutral pentavalent impurity doubly intrinsic semiconductor donates fifth orbital electron and becomes positive turn. So clearly the answer वही है जो हम पहले से दे रहे थे. Clearly, electrons will become majority carrier, but जो pentavalent impurity है उसके ऊपर positive charge है. That's why overall charge will be equal to 0. So इसका मतलब assertion correct है, reason correct है, correct explanation बिल्कुल correct explanation है. So answer is A here. We go to the next question. A series LCR circuit behaves as a pure resistive circuit at resonance. Obviously correct. We'll try to answer ourselves. Impedance of RLC is given by R square plus XL minus XC whole square under. At resonance, XL becomes equal to XC. So this part becomes 0. Z becomes under root of R square, that is R. So only resistance is left. So it becomes a purely resistive circuit because XL becomes equal to XC. So same is written here. in reason. So that means assertion is correct, reason is correct, and it is the correct explanation. So answer is again A for this. Question number 15. In double slit experiment, if one slit is closed, diffraction pattern due to the other slit will appear on the screen. Obviously, correct. Because single slit में diffraction नहीं होता है बेटा, हमने पढ़ा ही है. In double slit you see Young's double slit experiment. In single slit always diffraction pattern, it is correct. It is correct. And इसमें नीचे क्या लिखा, for interference at least two waves are required, ये भी correct है. But इसका कोई link नहीं है. क्योंकि यहाँ पे interference की बात चली, वहाँ diffraction की बात चली. There is no link. Single slit will always give diffraction pattern. Double slit will always give. But a double slit experiment cannot explain diffraction. So there is no link. Although both are correct. So answer is B. 16. For monochromatic incident radiation, the emitted photoelectrons from a given metal have a speed ranging from 0 to certain maximum value. Okay, correct. We know that photoelectric equation is kinetic energy maximum h nu minus work. Kinetic energy maximum we can also write it as half mv max square h nu minus work. Although the incident light photons have the same frequency, work function is also fixed, but still different electrons emitted have different kinetic energy, different velocities. Why does this happen? This is because all electrons are not emitted from the top layer of the metal. When light falls, suppose this metal, the photon can remove electron. This is photon coming. It can remove electron from top layer. It can remove electron from next layer, because electrons are emitted from different layers, so they will have different speeds. Because less energy will be required to remove this electron, more energy will be required to remove this electron. So assertion is absolutely correct. Different electrons have different velocities. Each metal has a definite work function. This is also correct, but it is not the correct explanation. Correct explanation should be that electrons are emitted from different layers. That should be the explanation. So answer is again B. So this is first part completed. Now we go to the second part of the paper. In the given figure, three identical bulbs P, Q, S are connected to the battery. Compare the brightness of the bulb P and Q with that of bulb S when key K is closed. First part. When key K is closed, this is closed, suppose. So some current will come from the battery, suppose I current. I current is passing through S. Now because two parallel paths are similar, because both resistances are same. So half current will go to that side, half current will go to that side. These two will get the same current. So इनकी brightness आपस में same होगी. But this is getting more current, S is getting more current. That's why brightness of S will be more and P and Q brightness will be equal. This is the first answer, first part. And what is the second part? See, brightness will depend on how much heat is produced. Heat produced formula is I square R. Whichever bulb will get more current will produce more brightness. So S will produce more brightness. And these two have same brightness, but brightness of S is more. Next is compare the brightness when key K is open of brightness SN. Now suppose in this case some other current I dash is flowing because resistance of circuit has changed. P is open now. Now in P there is no current flowing. All of the current that comes through S will pass through Q. Same current is flowing through SQ and no current is going towards P. That means it will have zero brightness, but S and Q brightness will be same. So this is the answer. First part answer is S is more, P and Q are equal. Second part answer is S is equal to Q, but brightness of P is 0. So that is the answer of this question. Now we come to this question. Two cells of EMF 10 volt, two resistance 20 ohm, 10 ohm. This circuit obviously already shown to you. They have asked it how much current is flowing to the bulb P. Obviously, you can see that this is a question of Kirchhoff's second law. So we have to find out current through this bulb. So I will start current. Suppose current is coming from this arm, I. Some current is going to this arm, I1, and remaining current, I minus I1 is going. Current is coming from one arm, going dividing into two arms, I1, I minus I1. I1 flows like this. I minus I1 comes from here. Then again, both the currents get added. I current is here now. Now we have to apply Kirchhoff law. For Kirchhoff law, there are different conventions used in different books. So first of all, for applying Kirchhoff law, you write your conventions. Suppose we have taken the convention that if there is lower to higher potential we are moving, then we will take it positive because we are moving towards higher potential. And if it is higher to lower potential, higher to lower potential, then it will take it negative. So first of all, lower to higher potential, take positive, higher to lower potential. First of all, write in the top. We are using this convention. Whatever convention you are using, that you should write first. Now we apply Kirchhoff law. So there was current I here, I1 here, I minus I. Again I. First we apply Kirchhoff's law in this arm. In the battery we are moving from lower to higher potential, smaller plate to the bigger plate, lower to higher potential. So plus 10. Again coming here, we are moving with the current. With the current it means we are moving from higher potential to lower potential. Whenever we move with current, take minus. We are moving from higher potential to lower potential. Then we are moving on this side against the current. So take plus, and I minus I1 is equal to 0. Close. So the equation becomes, on solving the equation becomes Ni minus plus 30 I1 is equal to 10. This is the equation on solving. Next, we take this path. With current we are moving, this is the path. Minus 10 I minus I1. With current minus 10. Smaller to bigger plate of battery plus 10. Smaller to bigger plate of the battery plus. Bigger to smaller plate minus. With the current we are moving minus. Opposite to current we are moving plus. These conventions should be used. Otherwise you can use your own convention as you like. So this will become 20I minus 10I1 is equal to 10. Solve these equations, you get this. Now on solving these two equations, we get I is equal to 0.8 ampere. You can solve this. I1 is equal to 0.6 ampere. You will get by solving these equations, these two equations. And we have to find current in this bulb. So that is I minus I. I minus I. That will be equal to 0.8 minus 0.6. Answer will be 0.2 ampere. You get answer. So it is very easy question. Kirchhoff law. It is not a difficult question. Now single slit, diffraction and single slit experiment. But we have to find out this for the angular position of the first secondary maxima. In diffraction for maxima, formula is A sin theta is equal to 2n plus 1 lambda by A. Lambda by 2n in diffraction. Okay. Because angle is small, in place of sin theta we can write theta. So 2n plus 1 lambda by 2 it becomes. So theta value will be odd multiple of A मैंने दो बार लिख दिया. Now it will come A है 2n plus 1 lambda by 2. Okay. Because it is first maxima, right? N is equal to 1. So theta becomes 3 lambda by 2. This is the answer for first secondary maxima. First secondary maxima. Now put the values. What is lambda? It is 550 nanometer, 3 by 2, 550 into 10 to the minus 9. And what is A? 0.55 into 10 to the minus. So you should solve this. On cutting, this will become 1000. On this also become 1000 up. 3 by 1.5 into 10 to the minus 3, or approximately 1.5 millimeter. So 1.5 into 10 to the minus 3 radian will be the answer. Radian will be the answer. I repeat it again. See this question again. A sin theta is equal to 2n plus 1 lambda by 2. First maxima, sin theta को theta लिख लो, 3 by 2 lambda. Theta की वैल्यू क्या होगी? 3 by 2 lambda by a. Put the values of lambda and a. What is lambda? 550 into 10 to the minus 9. A 0.55 into 10 to the minus 3. This will come out to be 1.5 into 10 to the minus 3 radians. Angular position of first secondary maximum. Question number 19. Equiconnex lens. Equiconnex lens like this. For equiconnex lens, first surface taken to be plus r, second surface taken to be minus r, radius of curvature. Effective index is 1.55. Focal length is given. We have to find out the value of r. So we'll apply Lenz Baker formula for this. Whenever focal length is related to radius of curvature, it is Lenz Baker formula. Formula you know, it is 1 by f is equal to n2 minus n1 upon n1, 1 by r1 minus 1 by r. Focal length is given to be 15, n2 is 1.55, surrounding medium is air, 1 by plus r minus 1 by minus r to become 1 by 15, 0.55, 1 by r minus will become plus, so it is 2 by r. So r will become 15 will multiplied by 0.55 multiplied by 30. Answer will be 16.5 centimeter. Radius of curvature 16.5 centimeters. Next question. Calculate the mass of alpha particle. What is alpha particle? Helium nucleus is 2 protons. Helium atom is 2 protons, 2 neutrons, and 2 electrons. This is helium atom. And what is alpha particle? When 2 electrons are moved, it becomes alpha particle. It is a nucleus of helium atom. Only this nucleus will be left. This is alpha particle. Alpha particle is the nucleus of helium atom. So basically, helium atom minus 2 electrons we have to do. Minus 2 electrons. So mass of helium minus the mass of 2 electrons. Mass of 2 electrons is approximately 0.000548, I think. That is mass of electron. EME, in EME, 0.00054. Mass of electron we have to minus. This much we have to subtract from the mass of helium atom, we will get the answer. It is 0.002603 minus 0.0001096. On subtracting, you will get mass of alpha particle. In this, you have to understand what is alpha particle. Alpha particle is nucleus of helium, basically. Helium atom minus 2 electrons. 2 electrons का mass minus करना है इसमें. Now this is a question on semiconductor. Every time you will get a question like this in semiconductors. Intrinsic semiconductor, intrinsic carrier density is given. This is Ni, intrinsic carrier density is given. Pure semiconductor में इतने electrons इतने holes equal है, intrinsic carrier density given है. On doping with impurity, hole concentration increase हो गई, PC, 10 पर 12 पहुंच गई. Hole concentration बढ़ने का मतलब क्या हुआ? कौन सी impurity डाली हमने? Acceptor impurity, trivalent impurity हमने डाली, तभी hole concentration बढ़ी. So which type of extrinsic semiconductor is found? It is p-type semiconductor is found. And we have to find out the electron concentration using the formula Ne into Nh is equal to Ni minus K. Electron concentration we don't know. Hole concentration we know 8 into 10 to the 12, 5 into 10 to the 8 intrinsic carrier density is here. So Ne becomes 25 into 10 to the 16 divided by 8 into 10 to the 12. This comes out to be 3.125 into 10 to the power 4. That is the electron concentration. That was a very easy question. Such questions will come from semiconductor chapter, always remember. And you can try similar question where impurity is donor. This is acceptor impurity. No? Similar question will be on donor impurity. Drive an expression, section C, drive an expression for resistivity of a conductor in terms of number and density of free electrons and relaxation time. This derivation basically derivation of Ohm's law, which is derived from two expressions: drift velocity E by m into tau, relaxation time into tau, and I is equal to NE and B. Substitute this value of AD here. So I will become NEA EE by m tau. Now what is electric field? NE square tau m area. Electric field is always voltage upon length. Now because voltage is directly proportional to current, so that means this is the Ohm's law. Ohm's law हमने प्रूव कर दिया. इस सारी क्वांटिटीज को इधर ले आओ. I m upon NE square tau length upon area voltage. So clearly this is Ohm's law and this quantity is resistance. So what is the formula for resistance? M upon NE square tau L by A. Now resistance given by formula R is equal to rho L by A. So on comparing this, you get this quantity is basically representing this resistivity. So this is a whole derivation of Ohm's law basically. Ohm's law की जब derivation करते हैं तो उसमें आपको resistivity का formula automatically अपने आप ही आ जाएगा. What is the formula of resistivity? This is a very important derivation. This derivation is important. This derivation is important as well as Ohm's law derivation is important. Out of these three, always one derivation will always come. Resistivity is m upon n is square tau. So that is the question. Next part. This diagram shows current versus time graph. And they have asked what is the charge flow here, what is the charge flow here. Because I to T graph, I to T is always charge. Or I dt is always charge. In case of graph, we always get only two informations. Either it is area of the graph or it is slope of the graph. तीसरी तो कोई चीज हमें ग्राफ से मिलेगी नहीं कभी. Because current into time integration आ रही है. Integration always represents area of the graph. Differentiation always represents slope of the graph. So because it is multiply or integration, it is area. तो इसका area बताना है. It is 2, it is 2. So this will become 2 into 2, 4. 4 coulomb charge is here. Triangle का area half base into height 2 2 half 2 into 2. So it is equal to 2 coulomb charge. So in first case it is 4 coulomb. In second case it is 2 coulomb charge. Just area. Always remember from a graph you get only two information. Either it is area of the graph or it is slope of the graph. Next part. Or part is good. A battery of EMF E and internal resistance R is connected to external resistance capital R. How much current is flowing? What is the expression of current? Current is total EMF divided by total resistance, internal plus external. This is current. This is the expression for current. Now say, what will be the maximum value of current? Maximum value of current will be when this resistance becomes zero. This becomes a conducting wire. No resistance is there, then current will be maximum. R को zero put करो. Maximum current कितना आएगा? E by small r. This is the maximum value of current. When the external resistance becomes zero, then current will be maximum. E by small r. If you conducting wire is conducted. In the second part, in the same question, obtain the terminal voltage. We know that terminal voltage of a battery is given by E minus I. That is terminal voltage. And when terminal voltage will be maximum? When no current is flowing through the circuit. When this battery, molar, and the applied resistance becomes infinity, then current flowing will become zero. No current will flow. Current will flow zero. That means voltage will be equal to E. Maximum value of voltage EMF when no current is flowing through the cell. Last part of this question. The above battery sends a current I1 when R is R1. So अभी हमने लिखा था करंट का फॉर्मूला क्या होता है? E small r plus capital R. Current is I1 when external resistance is R1. Current is I2 when external resistance is R2. So we can equate the values of E. It becomes I1 R plus R1 E equal to E. I2 R plus R2 is equal to E. Equate both values of E. I1 R plus R1, I2 R plus R2. Open the brackets and solve. I1 R, I1 R1, I2 R, I2 R2. Take smaller terms on one side and then solve. So we'll get R will be equal to I2 R2 minus I1 R1 divided by I1 minus R2. That will answer it. Internal resistance in terms of these 4 quantities. Next question. Question number 23A part. Vector form of Biot-Savart. You always know what is Biot-Savart law? Small magnetic field produced by small element is denoted by 4 pi ideal sin theta divided by r square. And what is its vector form? dV vector is equal to denoted by 4 pi ideal vector cross r vector divided by r. That is a vector form of Biot-Savart. Now, this question we have to answer. Long state conductor formula we know. What is the current? This is a long state conductor. This is a long state conductor, and we have to find current magnetic field at this point. Long state conductor formula is denoted by 4 pi 2y by r. There are two long state conductors. Let us see the direction of magnetic field. For this conductor, we will use right hand thumb rule. Keep the thumb in direction of current. Fingers will tell you direction of magnetic field. Current is up like this. Fingers show that magnetic field is inwards. Again here, current is like this. Magnetic field is outwards. For this, magnetic field is inwards. So magnetic field directions are opposite. We have to do vector addition, but because directions are opposite, simply we have to take minus. अगर same direction तो plus कर दो, opposite direction तो minus कर दो. Because इसकी डायरेक्शन इनवर्स है, इसकी डायरेक्शन आउटवर्ड है, जस्ट हमें माइनस करना है. एक का मैग्नेटिक फील्ड निकाल के दूसरा मैग्नेटिक फील्ड माइनस करना है. जो ये वाली वायर है, इसका डिस्टेंस है y कोऑर्डिनेट 5, इसका डिस्टेंस है x कोऑर्डिनेट 4. एक का डिस्टेंस 4 है, एक का डिस्टेंस 5 है. और जिसका 4 है उसका मैग्नेटिक फील्ड ज्यादा होगा. डिनोटेड बाय 4 pi 2 करंट 2 डिवाइडेड बाय डिस्टेंस 4 माइनस divided by 4 pi 2 formula we are using current to distance 5. The net magnetic field will be equal to divided by 4 pi common. 4 by 4 is 1, 4 by 5 is 0.8, so it is 0.2. Divided by 4 pi value 10 to the minus 7 into 0.2. This is the magnetic field produced at the point P. Okay. Question number 24. There are two coils here, coil 2 and coil 1. Coil 2 में एक बैटरी लगी हुई है, and we have to find the direction of current in the induced current in the coil 1. First option, when coil 2 is moving towards coil 1. In coil 2, this is positive plate, so current is flowing like this. एक तरह से आप कह सकते हो current is clockwise. Coil it will move like this, but overall it is clockwise. Now since coil is moving towards this coil, तो flux इसके साथ जो flux will increase हो रहा है, and according to Lenz's law, it will try to oppose, so it will produce a opposite current. If this is clockwise current, this will be anti-clockwise. There will be anti. This is clockwise, this will be anti-clockwise because it is moving towards. Flux is increasing. Anti-clockwise current and यहाँ आप कह सकते हो current will flow from O to P. Here the current is flowing from M to M, but their current will be flowing O to P, opposite of them. In second case, what they are saying, coil 2 is moving away from coil 1. Now, here the current was again clockwise. Now this coil is moving away, the flux is decreasing here. In this flux is decreasing. According to Lenz law, now this will try to help. The flux is decreasing. It will produce flux in same direction. So if current अगर यहाँ पे clockwise चला तो वहाँ पे क्या produce होगा फिर? Clockwise produce होगा. Because flux is decreasing. When flux is increasing, this current will be opposite to this. When flux is decreasing, this current will be in same direction. Now in the last C part, we are not moving coil 2, but we are increasing this resistance. हम इस resistance को बढ़ा रहे हैं. इस resistance को बढ़ाओगे तो obviously क्या है? Current is moving. Current is moving clockwise obviously, but resistance को बढ़ा रहे हैं तो current, this current is decreasing. This current is decreasing because resistance हम बढ़ा रहे हैं. Due to which again flux will decrease because current is decreasing. Flux will decrease again. Current will be in same direction because it will try to help. So it will be again clockwise. So in first part answer is anti-clockwise, but in second and third answer is clockwise. State any three characteristics of EM waves. So ये तो बहुत ही important topic है. EM waves की properties आपको तीन बतानी है कोई भी. EM waves can travel in vacuum. In vacuum they have speed 3 into 10 square 8 meter per second. These are made up of electric and magnetic field which are perpendicular to each other. So you have to write only 3 properties. But you have to learn at least 6-7 properties from chapter unit 5. Briefly explain how and where the displacement current exists during the charging of a capacitor. Okay. When we are charging a capacitor, this is capacitor, it is being charged by a battery. During charging, what is happening? This plate is continuously getting more and more positive charge, and this is getting negative charge. Positive charge is increasing here, negative charge is increasing. So electric field between the plates is increasing. Whenever in a region electric field is increasing or decreasing, there is always displacement current. ठीक है? So इस तरह से हम explain. During charging, electric field between the plates is increasing, so there will be displacement current. During discharging, again discharging also, if it is being discharged, the electric field will be decreasing. So there will be displacement current between the plates of the capacitor whenever it is being charged or being discharged, because displacement current arises due to variation in electric field. Question number 26. A double slit setup was initially placed in tank filled with water. It was in water already. Now it has been shifted to another medium of liquid which has an effective index even more than water. What will be effect on speed, frequency, wavelength? Speed के बारे में हमने क्या पढ़ा था बेटा? It is speed of light. Speed in medium is always equal to speed in vacuum divided by refractive index. Since refractive index is increasing, so that means speed it is increasing, so speed will decrease. Speed will decrease. So by shifting from water to this medium, speed will decrease. Frequency never changes. Whenever light moves from one medium to other medium, frequency will not change. Speed and wavelength both change. Wavelength will also change. Wavelength lambda dash in any medium is wavelength in vacuum divided by n. Again, same formula for as speed and wavelength. As n is increasing, so wavelength will be decreasing. So both speed and wavelength will decrease, but frequency will not change. Now, what will be the effect on fringe width? Fringe width is given by the formula lambda d by n. We have already discussed that wavelength is decreasing, so fringe width is also decreasing. Down arrow means decreasing. Since wavelength is decreasing, fringe width will also decrease. Shape of interference fringes will not change, but they will contract. सपोज पहले स्क्रीन पर फ्रिंजेस ऐसे बन रही थी, अब उनकी विड्थ थोड़ी कम हो जाएगी ऐसे। सेंट्रल मैक्सिमा, नो चेंज इन पोजीशन ऑफ सेंट्रल मैक्सिमा, बिकॉज सेंट्रल मैक्सिमा की पोजीशन वेवलेंथ पे डिपेंड ही नहीं करती, वो तो दो सिक्स के सामने वाले पॉइंट पे होती है, मिड पॉइंट, देयर इज सेंट्रल मैक्सिमा, यहाँ पे सेंट्रल मैक्सिमा बन रहा है, उसका पोजीशन से वेवलेंथ का कोई लिंक नहीं, दैट विल नॉट चेंज। स्पीड विल डिक्रीज, frequency will not change, wavelength will decrease, fringe width will decrease, fringes will contract like this, central maximum position will not change because it does not depend on wavelength. See, this capacitor has been shown here, plates P1, P2, P3, there is some medium in between, mica, they have called mica medium, medium is there. So this will be last question. Question number 27 first. Explain the following observation using Einstein photoelectric equation. This is basically the explanation of laws of photoelectric emission by Einstein equation. Photoelectric emission does not occur when frequency of light is less than certain minimum frequency. We know that Einstein photoelectric equation is kinetic energy is equal to h nu minus nu naught, where nu naught is threshold frequency, nu is incident frequency. If incident frequency is less than threshold frequency, this is the minimum frequency, उससे कम हो जाए, then this quantity will become negative, and because this quantity becomes negative, kinetic energy will become negative. But that is not possible. Kinetic energy can never be negative. That means this is not possible. So clearly, whenever frequency is less than threshold frequency, photoelectric emission will not take place. This is the first explanation, first part, A part. B part, it is frequency, not the intensity of light, which affects the maximum kinetic energy. Obviously, again same equation, I can show again. Kinetic energy maximum is equal to h nu minus work function. So clearly kinetic energy maximum depends on frequency. It depends on frequency. Intensity पे depend करता है number of photoelectrons. Number of photoelectrons will depend on intensity. The kinetic energy of electrons will depend only on frequency. C part. The cutoff voltage versus frequency, the graph is a straight line with slope equal to h by a. Okay. Einstein photoelectric equation is kinetic energy maximum or EV naught h nu or x equivalent minus h naught or work function. So this is basically kinetic Einstein photoelectric. You can use either of these two, either of these two, either of these two. In this case, what we have to use? Stopping potential and frequency required. Stopping potential and frequency required. So it will be EV naught. यहाँ से मैंने EV naught choose कर लिया, यहाँ से h nu choose कर लिया, इधर से work function. We have to plot a graph between V naught and frequency. Divide everything by E. V naught is equal to h by E nu minus work function by E. Clearly stopping potential has power 1, frequency has power 1, so obviously because both variables have power 1, so graph will be straight line. Now compare with y is equal to mx plus c, straight line equation, so clearly slope of the graph is this. On y axis we are plotting stopping potential, on x axis we are plotting frequency, so what is the slope of the graph? It is h by E. Very easy question again, theory. So see, you can see in paper there are many theory questions. Derivations may not be so many, but theory questions are so many. So properly derivations भी करो, theory questions भी करो, because you will get so many marks here. After that you can do numericals and conceptuals. What are majority and minority carriers of P type? P type में आपको पता है, P type में क्या होता है? In P type, holes are majority carriers, electrons are minority carriers. and in n-type, electrons are majority carriers and holes are minority carriers. Explain the formation of diffusion and drift current in a p-n junction diode. When a p-type semiconductor is placed in contact with n-type semiconductors, here holes are in larger quantity, p-type, n-type, electrons are in larger quantity. Initially, every particle will try to move from higher concentration to holes will try to move from higher concentration to lower. Electron will try to move here. So initially, spontaneously, the holes will move from P to N and electrons will move from N to N, higher concentration to lower concentration. This is diffusion. But after some time, a depletion layer will be formed. यहाँ पे डिप्लीशन लेयर बन जाएगी जिसमें ना इलेक्ट्रॉन होंगे ना होल्स होंगे. It will be negatively charged on this side. P साइड पे नेगेटिव चार्ज आ जाएगा, N साइड पे पॉजिटिव चार्ज आ जाएगा. ये जो इलेक्ट्रिक फील्ड है इसकी वजह से रिवर्स करंट चलना शुरू हो जाएगा. रिवर्स फ्लो, पहले होल्स इधर जा रहे थे, अब उल्टा चलना शुरू हो जाएगा. And that reverse current flow due to this electric field is known as drift current. So initially there will be diffusion current. After some time drift current will also start. Diffusion current will decrease with time. Drift current will increase with time. Ultimately both will balance each other. And then this depletion layer will require a constant thickness. When both these currents balance each other. Section B. This is a case study question. They have shown a capacitor with plates. Plates are rectangular plates. So this A has been given positive charge, B has been given negative charge. This plate will get positive charge on both sides, and opposite plates will get negative charge P1 and P2. So charge on P2 will be double the charge P1 and P3. So clearly two parallel paths are there. Charge is flowing like this and charge is also flowing like this. Two parallel paths are there. Total capacity will be infinite capacity at sided C plus C. So what is the capacity of upper? What is the capacity of lower? Capacity का फॉर्मूला आपको पता है क्या होता है? K epsilon naught E by D. यहाँ पे उन्होंने रेक्टेंगुलर प्लेट्स दिया हुआ है, तो एरिया की जगह L स्क्वायर आ जाएगा. स्क्वायर प्लेट्स दिया हुआ, सॉरी. Let us see. They are written here. Capacitor system will become between two capacitors, 2C. So 2 times K epsilon naught area. Area is length plus square plates are there divided by distance D. So this will be the capacity. So answer will be equal to C part. अगर ये नहीं किया तो हम ऐसे लिखते हैं 2K epsilon naught A by D. एरिया दिया हुआ है, स्क्वायर प्लेट्स हैं. So what will be charge on plate P1? Charge on plate P1 कितना होगा? Plate P1 पर charge बताना. Because they are connected in parallel. तो सेम वोल्टेज की प्लेट, पैरेलल वोल्टेज सेम रहेगी. अगर इसको वोल्टेज दी है तो इसको वोल्टेज दी जाएगी. इसकी कैपेसिटी है epsilon naught K epsilon naught A L square by D. नीचे वाली कैपेसिटी है K epsilon naught A L square by D. And what is charge? Q is equal to CV. This capacity multiplied by voltage. ये जो capacity है इसको multiplied by voltage करो. This will be charge on plate P1. Same charge will be on plate P3. और अगर P2 को पूछेंगे तो इन दोनों को ऐड करके बताना है क्योंकि डबल चार्ज है वहाँ पर P2 का. Q is equal to CV लगा के हमको निकालना है. So answer will be epsilon naught K L square D into V. Answer will be V part. What will be electric field between P and P2? Electric field, उसका potential difference तो पता है. Each कैपेसिटर both parallel में दोनों वोल्टेज सेम है. V electric field is V by D obviously. Both will have same voltage because दोनों कैपेसिटर parallel में लगे हुए हैं. इसलिए इसका आंसर रहेगा A part. then separation between the plates of same area L square of parallel plate capacitor. If it is air capacitor, so what should be separation? Same capacity लाने के लिए. अभी capacity हमारी क्या आई थी? Right, it was 2 times epsilon naught k L square by d. ये capacity हमारी. Now we have to use the air capacitor. Air capacitor में k नहीं होगा, epsilon naught, area length का square, distance d dash. और d dash को करना है सेम कैपेसिटी में. एप्सिलॉन कैंसिल आउट, l स्क्वायर कैंसिल आउट, d dash becomes d divided by 2k. Answer is d by 2k. Let's see. So they have asked me कौन सी एयर कैपेसिटर लेना है आपको उसके इक्विवेलेंट बनाने के लिए, उसकी क्या विड्थ होनी चाहिए सो दैट कैपेसिटी इज सेम. तो जो पहले कैपेसिटी आई थी उसको हमने एयर कैपेसिटर के साथ डबल करके d dash की वैल्यू निकाल. If source of potential applied between A and B is removed and then A and B connected by connecting wire. Suppose ये क्या कहना चाहते हैं? हमारे पास कैपेसिटर है, suppose any capacitor A and B plates are. If you remove the battery and connect these two like this, then obviously positive charge will flow to the negative charge, neutralize हो जाएगा. तो net charge क्या बचेगा? अगर किसी कैपेसिटर की जो प्लेट्स है दोनों को आपस में जोड़ ही दोगे बैटरी हटा करके, तो नेट चार्ज विल बिकम 0. होल ऑफ द एनर्जी स्टोर्ड विल बी कन्वर्टेड टू हीट. नेक्स्ट क्वेश्चन नंबर 30, अगेन केस स्टडी क्वेश्चन. इसमें आपको बोर थ्योरी के बारे में पूरी स्टोरी सुनाई है उन्होंने, पूरी स्टोरी. आफ्टर दैट व्हाट दे हैव आस्क्ड, और वो जो हम डेरिवेशन करते हैं वेलोसिटी रेडियस वही बात चल रही है यहाँ पे सारी. व्हाट इज द एक्सप्रेशन ऑफ स्पीड ऑफ इलेक्ट्रॉन इन टर्म्स ऑफ रेडियस? इन हाइड्रोजन एटम देयर इज अ न्यूक्लियस एंड देयर इज इलेक्ट्रॉन. न्यूक्लियस चार्ज प्लस Z होता है. न्यूक्लियस इज अट्रैक्टिंग इलेक्ट्रॉन. व्हाट इज द फोर्स ऑन इलेक्ट्रॉन? K. K means 1 by 4 pi epsilon naught. Q1 Q2 ZE E divided by R. Charge on nucleus, charge on electron divided by distance per square. This force acts as centripetal force. जो न्यूक्लियस फोर्स लगा रहा है वो सेंटीमीटर फोर्स की तरह से काम कर रहा है. सो हमें बताना है v की वैल्यू इन टर्म्स ऑफ r. सो एक r से r कट गया, m को इधर ले आओ, k z e स्क्वायर m r इज इक्वल टू v स्क्वायर. तो v की वैल्यू क्या आ जाएगी? व्हाट इज v? k z e square m r का अंडर रूट, that is, and z you can put 1 because it is hydrogen atom, so answer will be C part. hydrogen atom का z 1 होता है for hydrogen. टोटल एनर्जी कितनी हो जाएगी उसका फॉर्मूला बताना है. जिसको डेरिवेशन याद है उसको वैसे ही याद होगा टोटल एनर्जी कितनी होती है. अगेन सेम फॉर्मूला जो हमने अभी किया था, सेंटीमीटर फोर्स इज इक्वल टू m स्क्वायर बाय r. एक r से r कट गया, हाफ से मल्टीप्लाई करो, k z e स्क्वायर बाय 2r इज काइनेटिक, हाफ m स्क्वायर दैट इज काइनेटिक. और इसमें हाइड्रोजन एटम में हमने बताया हुआ है कि जो टोटल एनर्जी होती है वो माइनस ऑफ काइनेटिक एनर्जी होती है एंड टोटल एनर्जी इज हाफ ऑफ पोटेंशियल एनर्जी. इट्स अ रिलेशनशिप बिटवीन द एनर्जीज. So because kinetic energy का फॉर्मूला ये है, तो टोटल एनर्जी का फॉर्मूला बस इसके आगे माइनस साइन लगाना है और z को 1 पुट करना है हाइड्रोजन एटम के लिए. यदि इसका आंसर टोटल एनर्जी का आंसर बी पार्ट है. टोटल एनर्जी इज ऑलवेज नेगेटिव, पोटेंशियल एनर्जी इज ऑलवेज नेगेटिव, बट काइनेटिक एनर्जी इज पॉजिटिव. A photon of wavelength 500 nanometer is emitted when an electron makes a transition from one state to other in an atom. The change in total energy of electron and change in kinetic energy. Electron is emitted. That means electron is jumping from, photon is emitted means electron is jumping from higher orbit to the lower orbit. Whenever electron jumps from higher orbit to the lower orbit, its total energy will decrease, but its kinetic energy will increase. क्योंकि total energy kinetic energy में माइनस साइन है, always remember. Total energy will decrease. By how much total energy will decrease? Because it is moving from higher orbit to lower. वो आप फोटोन की एनर्जी निकाल सकते हो. Energy of photon is always equal to hc by lambda is always equal to energy in the higher orbit minus energy in the lower orbit. So energy के लिए आप hc by lambda फॉर्मूला लगा सकते हो. बट अगर हमें आंसर इलेक्ट्रॉन वोल्ट में निकालना है, जस्ट लाइक दिस, फोटोन की एनर्जी का फॉर्मूला hc by lambda होता है, बट अगर इलेक्ट्रॉन वोल्ट में निकालना है, इट बिकम्स hc by e lambda. दिस इज द फॉर्मूला फॉर एनर्जी इन इलेक्ट्रॉन वोल्ट. hc by e की वैल्यू हमें याद होनी चाहिए, दैट इज 1240 into 10 to minus 9. लैम्डा की वैल्यू 500 into 10 to minus 9. cancel out, this becomes 2.48. फोटोन की एनर्जी 2.48. so total energy decreases by this amount. total energy में माइनस आएगा और काइनेटिक एनर्जी में प्लस आएगा. सो व्हेनेवर वी मूव फ्रॉम हायर ऑर्बिट टू लोअर ऑर्बिट, टोटल एनर्जी विल डिक्रीज बट काइनेटिक एनर्जी विल इंक्रीज बाय दिस वैल्यू. सो इसका आंसर सी पार्ट आंसर. ऑलवेज टोटल एनर्जी एंड काइनेटिक एनर्जी आर अपोजिट रिलेशनशिप. सिंस टोटल एनर्जी इज डिक्रीजिंग, काइनेटिक एनर्जी मस्ट बी इंक्रीजिंग, बिकॉज़ टोटल एनर्जी माइनस में है, काइनेटिक एनर्जी प्लस में है. In Bohr model of hydrogen atom, frequency of revolution in nth orbit is proportional to how much? See, radius of nth orbit होता है 0.529 n square by z. Velocity in nth orbit होता है 2.2 into 10 to the 6 z by n meter per second. Time period क्या होता है? Length of orbit divided by velocity. इससे time period निकाल सकते हो. तो टाइम पीरियड में रेडियस के लिए ऊपर आ जाएगा n स्क्वायर, वेलोसिटी में क्या आ जाएगा 1 by n, n ऊपर जाके मल्टीप्लाई, टाइम पीरियड n के क्यूब के फैक्टोरियल ऑप्शन n ऊपर चला जाएगा. रेडियस में n स्क्वायर है, वेलोसिटी में 1 by n, और फ्रीक्वेंसी तो टाइम पीरियड का रेसिप्रोकल होती है, तो फ्रीक्वेंसी विल डिपेंड ऑन 1 by n क्यूब. टाइम पीरियड n क्यूब के फैक्टोरियल ऑप्शन है, फ्रीक्वेंसी 1 by n क्यूब के फैक्टोरियल ऑप्शन है. सो इट्स आंसर इज डी. An electron makes a transition from minus 3.4 electron volt state. आप सबने एनर्जी लेवल डायग्राम बनाई होगी तो आपको पता है फर्स्ट ऑर्बिट होती है माइनस 7.6, सेकंड ऑर्बिट होती है माइनस 3.2. तो इलेक्ट्रॉन इज जंपिंग फ्रॉम सेकंड ऑर्बिट टू द ग्राउंड स्टेट, ऑब्वियसली फर्स्ट ऑर्बिट. उसका रेडियस कितना चेंज होगा? रेडियस ऑफ nth ऑर्बिट होता है 0.53 into n square by z आंसर. For hydrogen atom, radius of first orbit will be 0.53 into 1 square, that is 0.53 angstrom. And radius of second orbit will be 0.53 into 2 square, that is 2.12 angstrom. Since it is jumping from second to first orbit, by how much radius is changing? It is changing by 2.12 minus 0.53, that is 1.59 angstrom. ठीक है, ओके. So now we do section E. In section E, there are 5 marks questions. So students should understand first that in section E you will have derivations, but you have to understand, you have to find out which derivation it is. Wordings will not be directly, so you have to identify which derivation it is. For example, this A part, 31st A part. Two charges plus Q minus Q are held at A0 and minus A0 in XY plane. Obtain the expression for net electric field at a point 0, y. See, this is x-axis and y-axis. A charge is placed at minus A, 0. A charge is placed at A, 0. Minus A 0 पर है चार्ज, minus Q here it is plus Q charge. So basically it is a dipole, and they are asking for electric field at a point on y-axis 0, y. So clearly you can understand this. This is derivation of equatorial line of dipole. But आप देख सकते हो डायरेक्टली उन्होंने इक्वेटोरियल लाइन वर्ड कहीं यूज नहीं किया है, तो आपको अपने आप दिमाग लगाना है. सारी CBSE बोर्ड में ऐसी ही डेरिवेशन आएंगी, ध्यान से देख के आइडेंटिफाई करके कौन सी डेरिवेशन है. तो इक्वेटोरियल लाइन की डेरिवेशन करनी है, ध्यान से करनी है. Okay. Next, B part. Second part of this. In this, there are three charges placed on vertices of a triangle. ये पोटेंशियल एनर्जी का क्वेश्चन है और नॉर्मली हर साल पोटेंशियल एनर्जी का क्वेश्चन आएगा ही आएगा. आपको ध्यान रहे A पॉइंट, B पॉइंट, C पॉइंट, -2 नैनोकूलम at A, at B -1 nanocoulomb, at C +5 nanocoulomb. Then they are shifted to points A1, B1, C1. A1, B1, C1. What is A1, B1, C1? A1 is midpoint of AB. B1 is midpoint of BC, and C1 is midpoint of C. Basically, they are being shifted to the vertices of smaller triangle. A वाले चार्ज को यहाँ शिफ्ट कर रहे हैं, B वाले चार्ज को यहाँ शिफ्ट कर रहे हैं, C वाले चार्ज को यहाँ शिफ्ट कर रहे हैं. So basically हमें वर्क डन निकालना है. Okay. So for that we have to find the initial potential energy, then the final potential energy. Potential energy का formula for a pair of charges होता है 1/4π Q1 Q2 by R. This is the formula for potential energy for a pair of charges. So there are three pairs of charges here. A और B का pair, B और C का, C और A का. So what is potential energy? Initial potential energy, let us see. 1/4π. तो कॉमन ही ले लेते, सब में सेम आने वाले, so we take it common. First charge is -2 and -1. -2 nanocoulomb multiplied by -1 nanocoulomb divided by distance is how much? 0.2 meters. This is the first pair. First pair. Then second pair is -1 and 5. -1 into 10 to -9, 5 into 10 to -9 divided by 0.2 plus the third pair. Third pair is 5 and -2. -2 into 10 to -9, 5 into 10 to -9 divided by 0.2. In all these terms, the common things we take out. What are the common things? 1/4π की value 9 to 10 पर 9 is common. 10 to -18 comes out common. 10 to -18 comes out common. इन सब में ही है, नीचे 0.2 भी सब में ही है. और ब्रैकेट में आ जाएगा -2 into -1 that is 2. -1 into 5 that is -5. -2 into 5 that is -10. So that is -13 basically. So this will come out to be -13 into 9 -117 by 2 into 10 की power -8. This is the initial potential energy. On solving you get this initial potential energy. अब इन चार्जेस को हमने बाद में शिफ्ट कर दिया कहाँ पर? यहाँ पॉइंट्स पे शिफ्ट. सेम चार्जेस आर देयर अगेन, बट डिस्टेंस कम हो गया बेसिकली. अगर पूरे ट्रायंगल का साइड 0.2 थी तो ये वाली साइड हो जाएगी हमारी, क्योंकि मिड पॉइंट से आप लेके गए दिस साइड विल बिकम 0.1 0.1 0.1 हाफ हो जाएगा, 0.1 हो जाएगा. बिकॉज यू नो दैट लाइन joining the midpoint of two sides of a triangle is parallel to the third side and half of it. ये 10th का एक basic theorem है. So distance will become 0.1 now. So in this case nothing will change, only the distance will change. So what will be the new potential energy? 1/4π will be common. 10 to -18 will be common. Distance instead of 0.2 will become 0.1. और ब्रैकेट में वही -2 into -1 and then -1 into 5 and then -2 into 5. Same pairs will be remain here. So this will become 9 to 10 to 9, 10 to -18, 0.1, and this will again become equal to -13. So potential energy will be equal to -117 into 10 to -8 joule per meter. This is the final potential energy. And what can be equal to what? Final potential energy minus initial potential energy. That you can solve yourself. माइनस करके आपका आंसर आ जाएगा. पोटेंशियल एनर्जी का क्वेश्चन जरूर आता है, ध्यान रहे, काफी इंपॉर्टेंट है. सो दिस अब इसका इसी क्वेश्चन का 31st क्वेश्चन का और पार्ट ले लेते हैं. दिस वाज 31st क्वेश्चन. नाउ और पार्ट ऑफ 31st क्वेश्चन वी गो टू दैट. In this, what they are saying is show that Gauss theorem is consistent with Coulomb's law. तो बेसिकली हमें गॉस थ्योरम से कूलम्स लॉ को प्रूव करके दिखाना है. We take a charge here plus q. We take a spherical surface, origin surface r distance. Charge enclosed is q. We apply Gauss theorem E dot ds over the closed surface will be equal to q by epsilon naught. Lines will be radially outwards. So lines के बीच में और area vector के बीच में lines अगर ऐसे जा रही हैं और area vector दोनों के बीच में एंगल 0 डिग्री रहेगा. स्फेरिकल स्प्लिट लिए तो हमेशा पता ही है, बहुत सारे डेरिवेशंस करते हैं इसमें. एंगल विल बी 0, सो डॉट प्रोडक्ट में आ जाएगा EDS cos 0 q by epsilon naught. E comes out, ds का इंटीग्रल स्फीयर का सरफेस एरिया 4 pi r स्क्वायर हो जाएगा q by epsilon naught. E की वैल्यू होगी 1 by 4 pi epsilon naught q by r स्क्वायर. सो ये जो फॉर्मूला है गॉस थ्योरम से हमने निकाला, बट ये तो पॉइंट चार्ज का फॉर्मूला है और ये कूलम्स लॉ से भी आता है. दिस शोज दैट गॉस थ्योरम एंड कूलम्स लॉ आर कंसिस्टेंट विद ईच अदर. They are basically substitute of each other. Because with the help of Coulomb's law we can prove Gauss theorem, and with the help of Gauss theorem we can prove Coulomb's law. This is a proof of Coulomb's law. And second part, spherical shell की निकालनी है अपने को. दो केस हैं. जब डिस्टेंस r से ज्यादा है means outside point, and distance r से कम है inside point, so there is a spherical shell है. Spherical shell means hollow sphere, चार्ज सारा surface पे है. Point is outside, more than the radius. Radius is smaller, you want to be radius smaller. We take a Gaussian sphere like this of radius y. Again apply Gauss theorem. Charge enclosed q again. E dot ds over the closed path will be equal to q by epsilon. Again angle will be same. E will come out. ds का इंटीग्रल हो जाएगा 4 pi y square. And electric field will be equal to 1 by 4 pi epsilon naught q by y square. So that is just like point charge. So for any outside point, spherical shell will behave like a point charge only. Point charge वाला फॉर्मूला ये आएगा 1 by 4 pi epsilon q by distance का scale. But if point is inside, if it is inside point, then what will happen? In case of inside point, what will happen? This is suppose inside point. Charge is on the surface. Point is inside and this is y. We take a Gaussian sphere. And we know that there is no charge enclosed because charge is सारा बाहर आएगा. इस Gaussian sphere के अंदर कोई चार्ज ही नहीं है. So then we apply Gauss theorem. E dot ds over the closed surface will be equal to no charge enclosed divided by epsilon naught, due to which electric field will also come out to be 0. So inside the spherical shell, electric field will be 0. Outside electric field होगा वो point charge जैसे केस होगा. Second part देखो इसका. यहाँ क्वेश्चन दिया पोटेंशियल का. See. In the same question जो पहले हमने किया था उसमें पोटेंशियल एनर्जी का क्वेश्चन दिया हुआ था, एंड एट द रिप्लेसमेंट ऑफ पोटेंशियल एनर्जी क्वेश्चन उन्होंने दूसरा कंपैरिजन में पोटेंशियल का क्वेश्चन दे दिया. यहाँ पोटेंशियल. सो व्हाट इज दिस क्वेश्चन? +2 nanocoulomb charge is placed at origin. Find the type and magnitude of charge that should be placed at this point so that the potential due to this at this point 002 becomes 0. So what they are saying is x-axis, y-axis, and sorry z-axis. Origin पर चार्ज पड़ा हुआ है 2 नैनो प्लस 2 नैनो. ओके, हमें पोटेंशियल निकालना है इस पॉइंट पर which is 0,0,2. And there is another point 0, 0, minus 6. 0, 0, minus 6. यहाँ पे कितना चार्ज रखा जाए Q so that potential at this point becomes 0. So obviously पता ही चला कि अगर वो पॉजिटिव चार्ज है इसका नेगेटिव होना जरूरी है तभी पोटेंशियल 0 होगा. So but we find out what is potential due to this charge? 1 by 4 pi epsilon naught 2 nanocoulomb divided by distance is 2 meter. Plus potential due to this 1 by 4 pi epsilon charge unknown q divided by distance हो गया -6 से लेकर 2 तक का डिस्टेंस हो गया 8. टोटल पोटेंशियल इज इक्वल टू 0. इस क्वांटिटी को उधर ले जाओ 1 by 4 pi epsilon q by 8. 2 से 2 कैंसिल आउट हो गया, उधर जाकर हो गया -1 by 4 pi epsilon into 10 to the -9. 1 का 4 एप्सिलॉन विल बी कैंसिल आउट, 8 उधर चला गया, q हो गया माइनस 8 into 10 to minus 9, that is minus 8 nano coulomb charge should be placed here. Then potential at this point will become 0. Okay. So this is completed. Question number 31st. Both over part is also completed. Now question number 32. This is from unit number 4. Electromagnetic induction and AC current. State Lenz's law. What Lenz's law says that direction of induced EMF is such that it always opposes the cause of its production. How does it obey law of conservation of energy? Because Lenz's law says that induced EMF will always oppose, induced current will always oppose the cause of motion. Due to this opposition, we have to do some work. Due to opposition by induced current, we have to do some work. हमें कुछ काम करना पड़ेगा. Because it is opposing, and that work done will be converted to electrical energy. So we can say that energy is basically being converted from one form to the other form. Energy can neither be created nor be destroyed in Lenz's law. This is the first part. In second part, so there is a magnetic field in this region. Cross means inward magnetic field है. यहाँ से एक loop आ रहा है. It is moving like this. Loop is moving like this. What will be induced EMF? What they have asked? They have asked कि induced EMF कब होगी? जब ये enter करेगा और जब ये बाहर निकलेगा. इसकी length alpha है. We know that whenever a coil enters a magnetic field, induced EMF का फॉर्मूला होता है BLV, when it will enter, और जब वो लीव करेगा तब भी BLV होगा. डायरेक्शन का डिफरेंस हो सकता है, but in this case length is not L, length is L by 2. So whenever this coil is entering like this, so there will be induced EMF BL by 2 into B. Again, when it will be moving inside, there will be no induced EMF, will become 0. When it is coming out, then induced EMF will become BLV by 2. So whenever it is entering or leaving, flux is changing, then there will be induced EMF. When it is moving outside, no induced EMF. When it is moving outside, no induced EMF. Only there will be induced EMF when it is entering or leaving. So that is about this. Now, what they have asked, let us see the question. First part, what will be induced EMF? Direction of induced current when loop enters and leaves a field. Induced current की direction पूछी है. So when it is entering, so this is Lenz's law based question. What is direction of original magnetic field? Cross means it is inwards. Lenz's law के जो क्वेश्चन होते हैं डायरेक्शन ऑफ करंट बताने वाले, इसमें 4 स्टेप्स होते हैं हमेशा. पहले ओरिजिनल मैग्नेटिक फील्ड इनवर्ड्स है. Since loop is coming inwards, so flux in the loop is increasing. If flux is increasing, then induced magnetic field will be opposite to the original. Inwards का opposite हो जाएगा outwards. Induced magnetic field will be outwards, and to make outward magnetic field, induced current will be anti-clockwise. So induced current will actually be anti-clockwise. Anti-clockwise. When it is entering and when it is leaving, same step. Original magnetic field inwards, but now flux is decreasing because it is going out. When flux is decreasing, then induced magnetic field will be in same direction as original. Inwards ही रहेगा decreasing के केस में. और inwards के लिए, keep the thumb inwards, induced current will be clockwise. So when it is entering, induced current will be anti-clockwise. When it is leaving, induced current will be clockwise. That is the answers of the first part. Now second part. Draw the plot showing the variation of magnetic flux phi linked loop with time t, variation of induced EMF with time t, and values भी आपको बतानी है. So how the flux will be? फ्लक्स का फॉर्मूला होता है B into A. B into A होगा फ्लक्स का फॉर्मूला, बिकॉज इट इज स्केयर लूप. जब पूरा का पूरा लूप हमारा मैग्नेटिक फील्ड के अंदर होगा तो एरिया उसका हो जाएगा L स्केयर, L by 2 का स्केयर, साइड इज L by 2, BL स्केयर by 4 विल बी मैक्सिमम फ्लक्स. So how the flux will vary with time? Initially loop बाहर है तो ऐसा ग्राफ बनेगा 0. Then as the loop enters, flux will start increasing, then it will become constant, then it will decrease, and then again will become 0 when the loop is out again. And this maximum value of flux when loop is completely inside magnetic field is BL square by 4. This is BL square by 4. It will start very increase from 0 to BL square by 4, then will decrease from BL square by 4 to 0. And what will be induced EMF? Graph. Induced EMF का graph कैसा होगा? जब फ्लक्स वेरी नहीं कर रहा, नो इंड्यूस्ड ईएमएफ. जब फ्लक्स इंक्रीज कर रहा है, इंड्यूस्ड ईएमएफ माइनस में होगा. अगेन फ्लक्स बिकम्स कांस्टेंट, इंड्यूस्ड ईएमएफ 0. अगेन फ्लक्स इज डिक्रीजिंग, इंड्यूस्ड ईएमएफ विल बी पॉजिटिव. एंड दिस वैल्यू ऑफ इंड्यूस्ड ईएमएफ विल हमने अभी निकाली थी, मोशनल ईएमएफ माइनस BL by 2 and this side will be plus BL. When it is coming inwards into the magnetic field, minus BL by 2. When it is going out, it will be BL by 2 plus BL by 2. So that is the answer in this case. Okay. Question number इसका और part 32 का B का और part. Differentiate between peak and RMS value of alternating current. How they are related? Suppose we have an AC current like this. AC. The highest value of current in a cycle is known as its peak. So peak value. Highest possible value is peak value. And what is RMS value? In this we have to define the RMS value. RMS value की definition देनी है. RMS value is that steady current which will produce same amount of heat in half cycle time or one cycle time as is produced by the given alternating current. That is definition of RMS value. और रिलेशनशिप तो आपको पता ही है कि RMS वैल्यू IRMS या हम सिंबल I भी यूज करते हैं. इट इज I0 डिवाइड बाय पीक वैल्यू डिवाइड बाय √2 या 0.707 I0. So that is the answer for this question. Next question. Unknown element X is there. Current element X is connected across AC EMF. Yes. It is found that voltage leads current by pi. That means अगर हमारे पास वोल्टेज ऐसे है तो करंट ऐसे है. वोल्टेज करंट से 90 डिग्री आगे चले. In this case, now X is replaced by another element Y, and now voltage lags. अब आपको पता है, हमने AC सेक्टर में पढ़ा हुआ है कि वोल्टेज लीड करती है इंडक्टर के केस में और वोल्टेज लैग करती है कैपेसिटर के केस में. सो द एलिमेंट X इज इंडक्टर एंड Y इज कैपेसिटर. आइडेंटिफाई द एलिमेंट्स X एंड Y. उनके फेजर डायग्राम बनाने हैं अपने को. फेजर डायग्राम्स फॉर X फॉर इंडक्टर, दैट इज जीरो फेज लाइन. दिस इज द फेज ऑफ EMF ओमेगा t या वोल्टेज एंड करंट उससे 90 डिग्री पीछे. In case of capacitor, zero phase line, this is EMF, omega t, and current 90 degree आगे चल. This is a phasor diagram for inductor. This is a phasor diagram for capacitor. Next, obtain the condition for resonance when both elements X and Y are connected in series to the source and obtain expression for resonant frequency. See, if resistance, inductor that is X and capacitor that is Y are connected in series, so what will be resonance condition? Resonance कब होगी? जब XL will be equal to X, तो resonance condition होगी. जब इसकी वैल्यू XL की वैल्यू XC के बराबर हो जाएगी तो resonance condition हो जाएगी. और हमें फ्रीक्वेंसी निकालनी है. XL होता है ओमेगा L, XC होता है 1 by omega C. यहाँ से ओमेगा की वैल्यू आ जाएगी 1 by √2 of LC. That is resonance frequency. And what is impedance in this case? आपको पता है impedance का फॉर्मूला होता है Z is equal to R square plus XL minus XC plus. जब XL XC के बराबर हो जाएगा, this quantity will become 0. So Z will be equal to only R square and root, that is R. Impedance अपनी मिनिमम वैल्यू पे आ रही है, that is equal to resistance. So that was a question number 32 completed. Now question number 33. An object is placed 30 centimeter from a thick thin convex lens of focal length 10 centimeter. Lens forms a sharp image on a screen. If thin concave lens is placed in contact with convex lens, एक और लेंस होती है concave lens उसके साथ जोड़ के रखते हैं. Sharp image of screen is formed when screen is moved by 45 centimeter from the initial position. Calculate the focal length of the concave lens. So second lens रखा उसकी focal length पूछी गई है. See, पहले हमारे पास एक convex lens जिसकी focal length है 10 centimeter. Convex lens की focal length plus में होती है. Concave lens की focal length minus में होती है. इसकी focal length plus 10 है. Object left की तरफ पढ़ाई होगा obviously 30 पर. तो हमें बताना है कि इमेज की पोजीशन कहाँ है. यहाँ पे कोई स्क्रीन है, वहां पे इमेज बन गई, रियल इमेज बन गई. स्क्रीन पे इमेज बनने का मतलब रियल इमेज बन गई. कहाँ बन गई? लेट अस फाइंड आउट यूजिंग लेंस फॉर्मूला 1/f = 1/v - 1/u. focal length 10. Object is to the left of the lens, so we take -30 according to sign convention. This will become plus 1/10 minus 1/30 1/v. So LCM ले लो, solve करो, it will be 15 centimeter. So image बन रही है 15 centimeter. 15 centimeter. अब नेक्स्ट में हमने क्या किया, इस लेंस के साथ में एक कनकेव लेंस रख दिया, जोड़ कर रख दिया, जिससे इमेज शिफ्ट होगी 45 सेंटीमीटर. स्क्रीन अवे चली जाएगी क्योंकि कनकेव लेंस तो कन्वर्जिंग इमेज डाइवर्स करता है. यहां पे इमेज नहीं बनेगी, स्क्रीन विल बी शिफ्टेड 45 सेंटीमीटर अवे. सो अब यहां कनकेव लेंस की फोकल लेंथ निकालनी है. ओके, सो वी मेक अगेन मेक द डायग्राम हियर. यहां पे हमारा लेंस के साथ कनकेव लेंस आ गया. ऑब्जेक्ट हमारा 30 पर है. इमेज पहले यहां पर थी 15, 45 शिफ्ट हो गई, यहां पे चली गई 45 शिफ्टेड. तो यहां पर स्क्रीन आ गई 60 पर होगी 60. अब हमें u भी पता है, v भी पता है. अब हम फोकल लेंथ निकाल सकते हैं. कॉम्बिनेशन की फोकल लेंथ आ गई. लेंस फॉर्मूला अगेन 1/f = 1/v - 1/u. फोकल लेंथ we have to find out. v की वैल्यू राइट की तरफ है 60, u की वैल्यू लेफ्ट की तरफ -30, 1/60 plus 1/30, 60 LCM 1 + 2. This comes out to be focal length 20 cm. Focal length is 20 cm. पहले फोकल लेंथ थी 10, अब कॉम्बिनेशन की फोकल लेंथ 20 होगी. इसकी फोकल लेंथ 10 है और पूरे उसकी फोकल लेंथ 20 है. हमें कनकेव लेंस की फोकल लेंथ बतानी है. अब लेंस कॉम्बिनेशन का फॉर्मूला लगाइए 1/f = 1/f1 + 1/f. कॉम्बिनेशन की फोकल लेंथ है 20, फर्स्ट लेंस की फोकल लेंथ है 10, सेकंड कनकेव लेंस की फोकल लेंथ हमें निकालनी है. इसको इधर ले आओ. 1/20 - 1/10, 20 LCM 1 - 2. So on solving you get f2 = -20 cm. So the concave lens must have a focal length of 20 cm. So this is a very good question. मेन काम तो बेटा लेंस फॉर्मूले का ही था, पर ध्यान से क्वेश्चन को समझ के करने की जरूरत है. Now this is a question on prism. Minimum deviation. We know that what is Lenz formula? Mu is equal to sin of a plus delta m by 2 divided by sin of a. Mu आपको दिया होगा 2, 3. इक्विलेटरल प्रिज्म दिया है, that means angle of prism is 60 degree. और हमें निकालना है एंगल ऑफ मिनिमम डेविएशन और एंगल ऑफ इंसिडेंस दोनों बताना है. ये एंगल ऑफ इंसिडेंस दिस इज आई. हमें डेल्टा एम भी निकालना है. पहले डेल्टा एम निकालना है. म्यू की वैल्यू है √3 sin of a is 60 degree plus delta m divided by 2 divided by sin of 60 by 2 that is sin 30 degree. sin 30 degree होता है हाफ, इधर जाके मल्टीप्लाई हो गया हाफ, √3 by 2 sin of 60 plus delta m by 2 What is root 3 by 2? It is sine of 60 degree. Root 3 by 2 is sine of 60 degree. दोनों तरफ sine हटा दो. 60 degree becomes 60 plus delta m by 2. So now you can solve to find out delta m. Delta m की value आ जाएगी हमारे पास 60 degrees. Minimum deviation is 60 degree. Minimum deviation तो आ गया. अब हमें निकालना है क्या? Angle of incidence बताना. Now this quantity is angle of incidence. What is angle of incidence? I is equal to A plus delta m by 2. Angle of prism 60. Minimum deviation is 60 divided by 2. So answer angle of incidence is also equal to how much? 60 degree. Next question. A physics teacher wants to demonstrate interference, double slit experiment. Wavelength is given, Young's double slit experiment है. Distance of ball is 5 meter. जहाँ पे इमेज बननी कैपिटल D given है आपको, और फ्रिंज विड्थ आपको given है. आपको बताना है कि स्लिट विड्थ कितनी है. बीटा इज इक्वल टू होता है लैम्डा D. Fringe width is given 5 millimeter, 5 into 10 to minus 3. Wavelength is 633 into 10 to minus 9. Distance of screen is 5 meter. Small d we have to find out. 5 से 5 को कट गया. Small d की वैल्यू आ गई, इसको चले जाओ. 633 into 10 to minus 6 meters. या 633 into 10 to minus 3 millimeters. Or you can say 0.633 millimeters. That is the slit width. दूसरा क्या निकालना है? फर्स्ट मिनिमा की पोजीशन बतानी है. मिनिमा के लिए फॉर्मूला that is called yn dash. मिनिमा का फॉर्मूला होता है 2n minus 1 lambda d by 2d. Because it is first minima, put n is equal to 1 here. This will become 1 lambda d by 2d. लैम्डा डी बाई डी की वैल्यू तो हमें पहले से पता है, फिर ऑलरेडी वी नो दैट इज 5 मिलीमीटर. दैट इज 5 मिलीमीटर. सो हाफ ऑफ 5, आंसर इज 2.5. पोजीशन ऑफ फर्स्ट मिनिमा इज एट 2.5 मिलीमीटर. सो दिस इज ऑन इंटरफेरेंस. सेकंड पार्ट इसका डायफ्रैक्शन वाला. यू सी दैट numericals are always coming on young double slit experiment as well as on diffraction. Diffraction में भी numerical आ रहा है. diffraction की theory भी आ सकती है, article भी आ सकता है. diffraction at single slit वाला numerical है. यहाँ wavelength दी हुई है आपको, slit width दी हुई है, screen 60 cm away है. हमें क्या निकालना है? what is distance between first order minima on the both sides of central maximum. This is सिंगल स्लिट एक्सपेरिमेंट. सामने स्क्रीन है. ये पैटर्न बन रहा है डिफ्रैक्शन पैटर्न. किसके बीच का डिस्टेंस पूछा? फर्स्ट ऑर्डर मिनिमा, फर्स्ट मिनिमा बोथ साइड्स, इनके बीच का डिस्टेंस पूछा. तो बेसिकली आप ये कह सकते हो कि सेंट्रल मैक्सिमा की विड्थ ही पूछी गई है. एंड व्हाट इज द विड्थ ऑफ सेंट्रल मैक्सिमा? इन डिफ्रैक्शन इट इज 2 लैम्डा डी बाय ए. इंटरफेरेंस में फ्रिंज विड्थ होती है लैम्डा डी बाई डी, बट हियर इट इज डबल. सेंटर मैक्सिमम विड्थ डबल होती है. 2 लैम्डा की वैल्यू 650 into 10 to minus 9. कैपिटल डी 60 सेंटीमीटर, 60 into 10 to minus 2 सेंटीमीटर को मीटर बना लिया. एंड देन स्मॉल a, स्लिट विड्थ इज हाउ मच? 0.6 into 10 to minus 3. So on solving we'll get the value of distance between minima on the other side, both sides. So क्या हो जाएगा? यहाँ पर आंसर देखते हैं. 0.6 को 60 से काटा, it will become 100. 2 into 650 1300 into 10 की power 5 10 पर minus 6 10 पर minus 6 हो जाएगा. Yes, it is 10 to minus 6. So it becomes 1300 into 10 to the minus 3. This was meters. This becomes millimeters. Ultimately, answer आ गया 1.3 millimeter is the answer. That's the distance between two minima on the either side of the central maximum. ये central maximum की width समझ लो 2 lambda है, which is 1.3 millimeters. So I think this question paper is completed now.